Audio equalizer. In this application, we are going to use an audio equalizer and apply FIR filtering to an audio signal. We will use a 4-second audio clip of a black-capped warbler. Here's the audio. Let's see what the sample rate of the audio signal is. And with that, we can plot the periodogram of the signal, as shown here. We can see how the magnitude spectrum of the audio signal changes over frequency. Also, the spectrogram, the time frequency plot of the audio, which basically shows how the frequency content of the signal changes over time. To apply the FIR filter, let's start by extracting the raw audio data from the audio clip. Also, the normalized frequency ranges for the 4-band equalizer that we are going to build will be as shown here. Let's show the 4 bands for these frequency ranges. First, the first band, the second band, the third band, and the fourth band. With the body plot, we can show the magnitude of the transfer function of the 4 filters that we defined. As shown here, they span the full frequency range with a low-pass filter, followed by 2 bandpass filters and a high-pass filter. Now, in the same way, we can build the 4-band equalizer and then apply it to our audio signal using the function listConvolve. To visualize the effect of the FIR filtering, we use the periodogram and show how the frequency content of the output changes. To create the equalizer, we use controllers for the values of the amplitudes corresponding to each of the 4 frequency bands. For our equalizer, we have set the initial values of the controllers for the amplitudes equal to 1. And so the periodogram of the output signal is going to be the same periodogram that we saw earlier for the initial audio signal. Now, if, for example, we set the first controller value or the value of the amplitude for the first band to 0 and keep the rest at 1, what will happen is that we'll remove most of the low-frequency wind noise, as shown here. The plot in blue shows the periodogram of the original audio signal. Next, if we also set the amplitude for the fourth band to 0, we will be also removing the frequencies above 10 kHz, as you see in the periodogram shown here. Let's also listen to the resulting audio signal after applying the FIR filtering in both of these cases that we just looked at. For the first case where we remove the low frequency wind noise, here is the resulting audio. And when we use the equalizer to also remove the higher frequencies, this is the resulting audio that we get. And here is the spectrogram of this audio signal. In this application, we studied the FIR filtering of an audio signal using an audio equalizer. We had a 4-second audio clip and we created a 4-band audio equalizer, and we used the equalizer on the audio clip. By adjusting the band magnitudes of the equalizer, we saw the effect of the filtering in a periodogram. We saw how the frequency content of the output signal changes.